Welcome to all. So in this video we will see the complement of a function. So in the previous part we have seen boolean functions as well as manipulation using algebraic concepts, but now we will concentrate on complementing of a particular function. How can we go for complements? Okay, the complement of a function is derived by interchanging dot and plus. You have to remember like that. So multiplication and addition, that concept come into picture here, and 1 and 0. So you can go for 1 and 0 as well as dot and positive symbol, and complementing each variable. So you have to complement each and every variable available in that particular function. So you will be having some instruction or function for f equal to some function. So if you want to complement it, you can you have to go for interchanging of dot and plus as well as 0 and 1, along with complementing each and every variable or literal. So we say literal, we use one keyword for explanation, that is literal. Literal are nothing but variables or its complements. Okay, so variables are nothing but some. See, if you go for x, y, z, see there are three variables. X is one variable, y is one variable, and z is one variable. Okay, so if you want to go for the complements, what you go for? You go for like x dash, y dash, z dash. That is a complement. Complement is nothing but inverting the thing. Okay, so otherwise interchanging ones to zeros in truth table, table column, showing one, there is one table in the next slide. So I will show you how exactly you can interchange it. Okay, the complement of a function is not the same as the dual of a function. So you have to remember. See, again, what you mean by dual of a function? You have to recall the concept of that postulate and list. Duality, I have already dealt in the previous video. Duality, so that is nothing but you should not say, for example, it's not same. If you complement of a function, if you go for the complementing thing, it is not same as the dual function. You should not confuse with that. It's a separate part of story. Okay, that is the one thing. You can go for the example here. See, find g xyz, g of xyz, then it is a complement of f xyz equal to xy dash z dash plus x dash yz. So this is the function. You have this function. Okay, now what you have to do? You have to find the g of xyz. Okay, now how to do that? So g equal to f dash. So f dash means, see, f means here xy dash z dash plus x dash yz. That is a function f. If you want to get the complement of the entire function, how can you do that? See, you can see there, f dash equal to xy dash z dash plus x dash yz to the whole dash. So you are taking the entire function and you are complementing it. You are not just touching each and every variable. Now you are taking the entire instruction or entire function and you are putting the complement thing. Okay, now how can you actually work on this complement? In the previous slide I said you have to interchange dot and plus, isn't it? So here you have plus, then you have to go for dot. That is multiplication using De Morgan's law. That is nothing but x y dash z dash to the power dash dot x dash y z to the power dash. Again, it is not like to the power, it is a complement, entire dash. You can go for complements. Okay, you should not say it to the power or something like that. But usually you represent this square, cube, and all you represent in terms of the power concept, right? So that is the reason why I said. But it is nothing but x dash y z whole dash. You can say like that. Okay, it is a De Morgan law. Now again you have to consider the De Morgan law again. So it is nothing but x dash plus y plus z dot, again x plus y dash plus z dash. How did you get this? How did you get the last line? So it is, again, you are interchanging dot and plus for complementing thing. Now x y dash z dash, it is a multiplication thing, right? X into y dash into z dash. What you are doing in the next step, you are taking complement of x dash plus complement of y dash is y, complement of z dash is z, because dual complement of complement is the same variable. correct? Dot, again x dash, complement of x dash is x, complement of y dash is, y is y dash, and complement of z is z dash. So you are going, instead of going for dot operation, you are going for positive symbol, plus plus. So you have, that is the reason why in the previous slide I said you have to interchange dot and plus, as well as 0 and 1. If you are dealing with numbers, then it is 0 and 1. Fine. The complement of a function can also be derived by finding the function's dual and then complementing all of the literals. So again, literals are nothing but variables. So they are saying that you can find the duals and then you have to complement of all the variables or literals available in your function. Fine, that is the concept. The next, canonical and standard forms. There are some canonical and standard forms which you have to understand. We need to consider formal techniques for the simplification of Boolean functions. So again, if see, one, you have already seen how to simplify Boolean functions, like algebraic manipulation, isn't it? By taking some postulate and you are reducing the function length. In the previous video you have seen, but in this video you are going for some techniques to simplify the Boolean functions. Okay, the first is identical functions will have exactly same canonical form. You have to remember, there's some points you have to remember. So when you have the identical functions, the canonical form also will be same. Next, you have the concept of minterms and maxterms. We will see what is minterms and maxterms. And you have some concept of sum of minterms and product of maxterms. Okay. Then you have product and sum terms. Okay. And next one is SOP and POS. That is sum of products and product of sums. Sum of products means whatever the products you have to add up. And product of sum means whatever the product you have to sum up. You have to get the summation. Something like that. Okay, so we will see one by one. Before that, you go for some definitions. Let's see, literal means it's a variable or its complement. Then product term means literals connected by dot symbol. It is just a multiplication, normal multiplication. Generally in mathematics we use that term, isn't it? Multiply or multiplication. But here they go for literals and product term. They use the keyword like product term. Okay. Next, sum term means literals connected by plus symbol. Next, minterm means a product term in which all the variables appears exactly once, either complemented or uncomplemented. So what you mean by minterm? Minterm is nothing but it is a product term actually. So using that dot operator only you are working. But the variables has to appear only once. It may be x or y or z, anything, but only once it has to appear. Then it can be in either it can be in a complemented form or uncomplemented form. Anything is fine. That is called minterm. So maxterm means a sum term in which all variables appears exactly once, either complemented or uncomplemented. So minterm is for product term and maxterm is for sum term. What do you mean by sum term? Sum term means literals connected by positive plus symbol. That is the main difference between minterm and maxterm. So these are the definitions which you have to understand. Now see, you can go a little bit in depth with respect to minterm. Represents exactly one combination in the truth table. Why it represents only one combination in truth table? Because anyway you are going for product term in this minterm concept. In product term also variables appears exactly once. So you have to remember like that. Okay, next, denoted by mj, where j is the decimal equivalent of minterm's corresponding binary combination, that is bj. Okay, j is nothing but the decimal equivalent. Okay, you have to say, you will see the truth table in the next slide, in the last slide. Okay, now a variable in mj is complemented if its value in bj is 0. That is, bj is nothing but a binary combination, j is nothing but the decimal equivalent. Now when you have variable in mj, okay, mj is nothing but the minterm, okay, minterm value. Fine. So it is complemented if its value in bj is 0. So if the value is 0, it is complemented. Otherwise it kept uncomplemented, like that. Now example is, assume 3 variables. So there are 3 variables a, b, c, and j equal to 3. If that is the case, then bj equal to 0, 1, 1. Okay, and its corresponding minterm denoted by mj is equal to a dash bc. Okay, why it is a dash? Because 0. bj is bj in bj value a is 0, b is 1, c is 1. So when a is 0, you have to complement it. So a complement, and b and c value is 1, so you are not complementing it. It will be kept uncomplemented. Okay, that is what they said in third point. So mj is complemented if its value in bj is 0. So a value is 0. That's why when you go for mj, you are complementing it. If the value is 1, you are not complementing, you are keeping as it is. That is the concept of minterm. Okay, so when you go for max term, it represents exactly one combination in the truth table denoted by mj, where j is the decimal equivalent. Same concept, max term corresponding binary combination. The variable in mj is complemented if its value in bj is 1, otherwise uncomplemented. So it is completely ulta. In minterm, what you have done, max term is completely ulta, or vice versa. You have to go for inverting the things, where if the value is 0, you have to keep the variable as it is. If the value is 1, you have to get the complement. See example 3. Assume 3 variables a, b, c, same thing, j equal to 3. Then bj equal to 0, 1, 1. That means a value is 0, b value is 1, c value is 1. Okay, its corresponding max term is denoted by mj equal to capital M, j is equal to a plus b dash plus c dash. Why it is a plus b dash plus c dash? Because a value is 0, you have to keep the variable as it is. B value is 1, then you have to go for the complement. C value is again 1, so you have to go for the complement. That is the reason why ultimately you got the function like a plus b dash plus c dash. So that this is the concept of max term. So this is the main difference between minterm and max term. Okay, so these are the two concepts which you have to understand. So this is the truth table I was mentioning previously. So minterms and max terms are easy to denote using the truth table. So example you can take, there are 3 variables x, y, z, and order is fixed, they said. Okay, so you have 3 variables, you have 7 rows, isn't it? You have to go for 7 rows. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So 0 to 7. When you have 3 variables using 3 bits, you can represent mainly from 0 to 7. Okay, now you can concentrate on minterm and max term. Okay, for minterm, what you have to do, when the variable value is 0, you have to get the complement. So that is the reason why x dash, y dash, z dash equal to m naught. Why it is x dash, y dash, z dash? Because x value is 0, y value is 0, z value is 0. If that is the case, in minterm, what you have to do, when the value is 0, you have to get the complement. But in max term, what you are going to do, you are going to do go for the exact ulta opposite. So you are keeping as it is max term x plus y plus z. So in max term, you are going for positive sign. In min terms, you are going for dot symbol or multiplication thing. That's why x, y, z, x dash, y dash, z dash equal to 0. That is nothing but x dash into y dash into z dash equal to m naught, like that. Okay, in the same fashion, in the second line, what you are going to do, you are going to complement x value, z y value, but you are keeping the z value as it is. Why? Because z value is 1 in minterm. So when the value is 1, mainly in terms of minterm, you have to keep the variable as it is. So that is the reason why you got the function like x dash into y dash into z equal to m1. And it is for max term, it is completely ulta. If you get minterm, you can get the max term very easily. You have to replace dot with the plus symbol, and you have to write the variable in ulta form. It is nothing but x plus y plus z dash equal to capital M1. So this is the main difference between minterm and max term. So you can go through that truth table completely. You can take your own values. You can go for 4 variables. Say for example w, x, y, z. So from 0 to 15, you can get the value 0, 0, 0, 0 to f, 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 f. Or you can go for some if you have 4 values, you can go for 5 total 5 rows also, 2 rows also, your wish. Any value is fine. Okay, but ultimately you have to understand the main difference between minterm and max term. That's it. Fine. So these are the concept of minterm and maxterm. You have one more concept, product of maxterms. Now just we can concentrate on product of maxterms. So each of the 2 to the power 2n function of n binary variables can be also expressed as product of maxterms. To express the Boolean function as a product of max terms, it must first be brought into a form of OR terms. OR terms are nothing but, see, when you have max term, I already said you are using positive symbol, plus symbol. That is nothing but OR. You are ORing it, correct? So this may be done by using the distributive law, x plus yz equal to x plus y into x plus z, using distributive law. Okay, then any missing variable x in each OR term is ORed with the x into x dash. What do you mean by x into x dash? It is 0, isn't it? Using postulate, some postulate number is there. So x into x dash is 0 and x plus x dash is 1. You have already seen in the previous video. Okay, so this procedure clarifies by they have gone for one example. We can directly go for the example. Express the Boolean function f equal to xy plus x dash z in a product of max term form. So if the question is like that, what you have to do? First you have to convert the function into OR. How can you convert the function into OR? You have to go for the distributive law. Okay, how can you do that? Xy plus x dash z. So if you apply distributive law, what you are going to do? What you are going to get? You are going to get xy plus x dash into xy plus z. You are distributing it. Now once you get xy plus x dash and xy into xy plus z, how can you reduce further? You can go for x plus x dash and y plus x dash. How? Again distributive law into again x plus z and y plus z. Now you know x plus x dash is nothing but 1. Correct? So you remain with the x dash plus y, x plus z and y plus z. Fine. Now from where x dash plus y you got? It is nothing but y plus x dash. Both are same. Y plus x dash and x plus y dash. Ultimately you are going to get the result same, right? So this you are actually further you are reducing or you are converting the function into some or using distributive law. Once you get that, then the function has 3 variables now, x, y, z. Each OR term is missing in one variable. Okay, now there is one variable that you are going to get the OR term will be missing. So how can you do that? X dash plus y equal to x dash plus y plus z into z dash. Why? Because in the first variable, in the out of 3 variable, first variable you are missing z. In the second variable you are missing y. In third variable you are missing x. So even though you have 3 variables in xyz, in this function you are missing something, some values. That is the reason why you have gone for this fashion. See, you can see x dash plus y equal to x dash plus y plus z into z dash. Now what is the value of z into z dash? It is 0. You are not changing anything there. Even though you add some new values there, you are not changing the actual function there. Because 0 has no values as of now, isn't it? For this function also, you don't have the value for 0. Why they introduced z into z dash? Because they want to make the function complete. They cannot leave any variables, they cannot miss any variables. That is the reason why they introduced z into z dash concept. Again, that is a postulate. That is one postulate. Okay. Now, after that, what they are doing? They are again going for distributive law, x dash plus y dash plus z into x dash plus y plus z dash. In the same fashion, for x plus z also they have gone for x plus z into y dash. Same concept. For third option also, y plus z plus x into x dash equal to same thing, distributive law. Once you get all these, now combining all the terms and removing those appears those that appear more than once, we finally obtain what we are going to obtain. Finally we are going to obtain the function equal to x plus y plus z into x plus y dash plus z into x dash plus y plus z into x dash plus y plus z dash. So you are combining everything. and removing those that appear more than once. If you have same variables more than once, if it is appearing, you have to you can remove it. Now you are going to get some notation, m0, m2, m4 and m5. Some notations you are going to give. So x plus y plus z is m0. Okay, in the same fashion, x plus y dash plus z is m2. From where you got this m0, m2, m4, m5 and all? Come here. So from here. Okay, so m0 is x plus y plus z. So here also see, in max term, under max term, x plus y plus z is m0. So from there, from that truth table, they taken this. Okay, convenient way to express this function is as follows. So f of xyz equal to, so you can go for 0, 2, 4, 5. From where they got 0, 2, 4, 5? From m, that indication, you have symbol, right? m0, m2, m4, m5. From there they just gone for some numbers. That's it. So it is a convenient way. They say that it's a convenient way by taking some constant, some value. It may be pi or any value there, delta, alpha, anything is fine, but they have taken one constant. That's it. Fine. Now the product of symbol denotes that ANDing of max term. So here they cannot just go for that. They are using some appropriate thing itself. If they are, but even though you use some constant values, if don't use it, but if you are deriving some your own logic, if you are deriving some your own thing, but if you are going for some special symbols, then you have to mention why that you have used some special symbol. But here it is a product symbol itself. So product symbol, why? Because m0 into m2 into m4 into m5. So you have that dot or ANDing concept. That's why they have gone for that product symbol. Okay, the numbers are the max term of function. So this is the concept of product of max terms. Okay, so like this you can derive some function and you can convert it to max terms by ORing it. First you have to OR it, then you can apply distributive law. Once you apply distributive law, then you can go for combining all the variables. But if you have identical variable or similar variable, you can eradicate it, you can just delete it, and ultimately you will get one function, and you have some symbol or notations, or you can go for some convenient expression also. You can express the function in convenient way using some product symbol and all. Okay, so this is the concept of max term, product of max term. If the question is like, see, express the Boolean function of some f equal to some value into some product of terms, means max term means you have to go for like this. So you can OR it, then once you get the OR thing, then you can go for this one, what you say, distributive law. Once you get the distributive law, you can combine all the function, and you can remove some identical or similar variable, and you can get the ultimate function at the end. Fine. So this is the concept of product of max term. So you have to mainly see the difference between minterm, max term, some definitions you have to understand, and then product of max term also. There are some other concepts involving. I will give the information in the next video, but as of now I hope you understood. So if you have any doubt, you can approach me, no issues. And let me wind up the video here. So I have taken this sheet from your textbook itself. I am not adding any new concept here, but if you want, you can take your own example. If you stuck somewhere, you can get back to me. Okay, so yes, yeah, thanks for watching. Thank you.